session, we hate code, the not joy of maintaining that code. This is not from me. So it's one of our customers said, we hate code. And I was like, oh, wow, that's a statement. Yeah, we will come to the point why. Oh, yeah, I was told that you can ask questions by scanning that. Unfortunately, I have no idea how it works. So whenever you have questions, they will be recorded. And if I can't answer them here, just find me on the floor and then we can discuss there. So I will be here today, the whole day. So it might be easier. My name is Gerrit Grunwald. I'm working for Azul, as you can see. We do JVMs. I also have a Java user group in Münster. By the way, who's member of a Java user group here? Very good. Good. Who knows that? Build now, fix later. You probably, do we have consultants in the room? Because they are mainly affected by this. I didn't saw that really in product companies, but I saw that a lot in consultancy projects. So just do it, come on, the deadline, we have to fix it now. I mean, build it now and fix then whenever, never. And who loves to maintain bad code? Who does code maintenance here on a regular basis? Okay, and you all love it, right? Well, it depends. It depends on the code you have to maintain, right? And bad code is, I don't mean really code that looks bad. It's two types of bad code. So there's legacy code, which is not always bad in the way the word is, and there's dead code. And this is not hard definitions. They change. So how I define it, the legacy code is, you know all that, right? I just go through it shortly. Code that was written for operating systems or hardware that doesn't exist anymore, or only in your whatever production environment maybe. It cannot be tested automatically, it's no longer developed or maintained by the original developer, lacks documentation. In short, it's code that you are afraid to touch, usually, right? It works, which is fine, but you better don't touch it. Well, how to deal with it? We all know that. We can refactor the code, we can rewrite everything. Who did a complete rewrite here in the room? Oh, okay, more than I thought. And you can find out if it is used at all. Because this, and we will see why this is also a valid point. So refactoring, yeah, you need to understand the code first, right? It helps a lot. And you can make use of static code analysis tools like checkstyle, whatever, you name it. There are so many tools that you can use that help you with that. Biggest problem with refactoring is mainly time. Because usually it's like, yeah, we have to do it. Priority is -1. So maybe we can do it next year, or maybe the year after, or maybe never. We will see. But this is usually what I saw when you go to your manager and say, I'll find some code, we have to maybe refactor it. Oh yeah, good point. Yeah, I will make a note. Oh, okay, that's it. Oh, create an issue. Yeah, cool. And then it's there, and a year later you check it and it's still there. Nobody's working on that. Well, rewrite, even worse, right? Because if you have to rewrite something, you also need to know the requirements of the original project, which is sometimes, if it's an old one, that's terrible because the people who created that code probably are not in the company anymore. So it's like, yeah, I know there was this guy, but he left the company 5 years ago. He did it. Okay. Well, hard to figure out the requirements. And then again, you need to know exactly what the code does. It's in principle like a new project completely with all the stuff that is involved, also the costs. So the main problem is time and money, right? Because this is really expensive and companies usually avoid doing that. Usually they just phase it out. Okay, we just use it as long as it's needed and then we create something new on the side and make the switch later on. At least that's my experience. Well, one question still remains is it used at all, right? And I wasn't really aware of that before I looked into it, and it's quite interesting, which leads me to dead code. And dead code, and this is how I define it, you will find different definitions on the web. There's not really a fixed definition for that. Is if you have unused imports, variables, methods, classes, and all these, right? Or unreachable code, sure. Redundant code, obsolete code, commented out code, and we all know that. And the risk of keeping that stuff in your code base is, for example, you increase complexity. If you have new colleagues joining the company and you sit them in front of the project, you give them something to do, they have to learn the whole thing. If it makes sense or not your problem, right? So why is this commented out? Oh yeah, we thought we might need it in the future. Ah, okay. And for what? For this function. What is it for? Ah, no idea. Just tried it. Don't touch it. Just take a look. You don't have to. It's really, it gets more complex if you keep that stuff. You have reduced performance probably, because if you have code that is not used, you think, okay, how can it reduce performance if we don't use it? It can. Right? We can't go into detail. We just have 45 minutes, but it is possible. You probably introduce bugs by code that is not really used because you open doors, right? Which leads to security vulnerabilities. And the last part, code reviews, getting harder and harder if you have to review all this stuff there and you have no idea if it's really used or not, right? But this is also that code you can find. No, it's not too hard. And oh yeah, I found something about possible costs, which is also interesting, because they said it's probably around 20 to 40% of all the cost for maintenance is just for that code, for stuff that is lying around and is not used. And another one says, oh yeah, probably $2 to $5 per line of that code that you have to spend. I have slides where we have numbers in the range of $85 billion a year, but this is for the Americans because they love the big numbers. If you would like to find out more info, there is an interesting blog post about that, and there you will find the big numbers that really are impressive for managers. But they really give you all the examples why it is so expensive to maintain code that is not in use anymore. That's good. I mean, where does it come from? All this dead code? Probably from build now, fix later. You add stuff quickly to fulfill the deadline. Yes, it is on your plan to fix it later, you never do. You keep the code and then it stuck in the code base forever, right? And who knows that? Who does library development here or other stuff? I mean, this is how like to remove code from your own library. Sometimes it's good and sometimes like, maybe I need it. That's a really nice function. I will keep it, probably for future use, and then you never use it instead of directly removing it because it's the fear of, oh, maybe I forget about it, right? But we have source code systems where we can have it in a repository and just get it back, but people are really hesitating to delete code, which is one of the problems, right? Or incomplete refactoring, another thing, where you have the problem that code that might not be refactored correctly sticks around and you keep it in your refactoring and then everybody says, oh yeah, we refactored it, it's great, but it still contains the old code in there because you didn't really completely refactor it correctly. Or merging code branches. If you have the same thing, 2 branches, you add duplicate code, nobody really checks, oh, the tests are green, perfect, merge it, done. Nobody really checks if there is that code in there. And the lack of awareness. If you have really big projects, I was once in a project in Singapore where we had a huge code base. And it's so hard to tell if the code that is not written by your team is in use. You just don't touch it. You just, I'm not sure, just there will be a reason for it, right? So removing this stuff is not that hard because we have solutions like who's using IntelliJ here in the room? Okay, who's not using IntelliJ here in the room? Okay, Visual Studio Code, someone? Eclipse? NetBeans? Nobody? Oh, damn it. But yeah, these IDEs have tools to remove code, right? If you have something like this, which is pretty simple, and let's say method 3 is not used, then in IntelliJ it just tells you, okay, you have this variable, you have this method, you can remove it, right? It's not in use. That's easy, that's the easy stuff. And the same is going for SonarQube IDE. If you don't know it, it's also a nice tool where you have more or less the same, but it's more configurable. But you can do the same stuff. So it will find the code for you that is not in use, which is nice. Problem with this stuff is it's not so easy to run it on the complete code base and remove stuff automatically everywhere, but it is possible. And you would like to take a look at it, so you don't want to remove just stuff, right? It's not so easy. But this is easy to find at least. SonarQube IDE, I think it was SonarQube Link or Sonar Link before. Now it's SonarQube IDE, which is the IDE plugin. It's for free, and it can do good stuff to your code. Just try it out. Then there's Open Rewrite. Who knows Open Rewrite? Who uses Open Rewrite? Oh wow, that's a couple of people. It's a community-driven open source project by Modern. Enables developers to effectively eliminate technical debt, right? So for example, they have a auto refactoring engine, and they have so-called recipes that you can use to, for example, remove, in this case, unused variables and methods and stuff. So that means you have the same piece of code, method 3 is not used, and in your, let's say you have Maven, then you can use this plugin from Open Rewrite, and you see the name of the recipe there, which is remove unused private methods. And then if you do mvn rewrite run, before that it looks like this, and afterwards it's just gone. This can remove code from your code base. Then you have to do the merge request and have to review it, of course. But at least you can use that on your code base. Makes things very easy. So quite powerful tool, and they have recipes for all kinds of stuff. So really cool stuff, and you can find it on GitHub. And also in the meantime, there's a marketplace where you have all the recipes and all these things. So that's quite useful. If you don't know about it, just check it out. It's absolutely worth it. Okay, but this is all stuff that is easy to find. What about zombie code? Who knows what zombie code is? Because that's interesting, and I wasn't aware, because zombie code is maintained code. Usually you have even tests for that, which might even already be the worst part. But it is never executed in production. That means the only code that executes your code is the test. That means in IntelliJ you won't find it because it's in use, right? Which makes it really hard to find. And then people most of the time say, yeah, come on, it couldn't be that much. Well, it's really, we have a customer, and I'm not allowed to name or to tell you the name. I can tell it to you outside later on if it's not recorded. But this customer, it's a big one. They ran it, these tests, and they figured out that they had 70% of the code wasn't used in production. And that was shocking for them. So first we thought about, should we really tell them? Maybe we just tell them it's 50%? Then we told them, no, it's 70 something. And it was really like, what? And you think about what is it? So it's, for example, you have a user interface, you have REST endpoints. How do you know if the customer really is using these REST endpoints? How do you use that? This stuff is really used in production. You have all these feature requests, you implement this stuff, you put it in production, but if you don't monitor it, you will never know. And one example is you have a product, for example, insurance company, you have a product for a specific use case. And then this is 10 years old because it never changed. But then someone had the idea, oh, we do this new project because there's something new, whatever. And oh, by the way, we just add the other functionality too. So suddenly you have both in your system. Now the question is, is the old part still in use or not? Or just the new stuff? Hard to tell. And then it leads to the fact that, we don't know. Just keep both. Just make sure everything's fine. This is, it sounds like, we won't have the problem, but I will tell you, you will have. Another example is this one. You have a developer say, oh, I have to do this matrix multiplication in Java. I have no idea how to do it. Ask the second dev. Oh, there's Apache Commons. There's a method in there. Cool. I just add it as dependency. Nice. We all know that. This is what it is. It's 224 methods and 16 classes, and you use one method out of it. And this is not just one library. We do that all over the place. And that leads to the fact that your artifact, after all, gets bigger and bigger because you add the whole library. But the code in the library is usually not used, most of it, which is in principle not a problem because sometimes you can't avoid it. But in this case, it's just this. It's 2 methods. And we are just too lazy to write it on our own because this is well known. People know about that stuff. Oh, there's a library, just use the library. Come on, add it. This was a request by another customer. They said, oh, could you figure out how many libraries we use where we only use 1 method or 2 methods? And it's a lot because this customer was a different one, also a big one. They would like to reduce the size of their artifacts because they have so many dependencies that the artifact is really big. And they've had the impression that maybe we don't use all of these artifacts really, and it was exactly this, right? But they didn't know. So that was just 2 methods you have to add, but we saw it was 224. Well, how to find this stuff? How to find code that is not used? Well, you can only do that in a running system. You can't do it statically because the code has to run to figure out that it's not running, which sounds strange, right? So one thing you can do is Tombstone Logging. Someone know what that is? It is pretty simple. It sounds weird, but it works. So what you do, if you use Log4j, for example, you can create custom log levels and use static initializers in the classes. And then this could be an example of a custom log level in Log4j. You have a log level for used class and used method. And in the code, what you do is in every class, you add a static initializer. And in every method, you add the log output. That sounds like a lot of work. And it will create huge log files, right? But with this, you can make sure that every time you call a class, it will call the log output from the static initializer, and also for every call of the method, it will log out that the method was used. Okay, so that leads to the fact that you get something like this, right? So method 3 doesn't appear, it wasn't used. Okay. That's okay, but it's a lot of stuff that is used and just minor stuff that isn't used in this case. You can do the same stuff with flight recorder. Is using someone flight recorder and mission control? Just a few. Oh, you should do it. It's really nice. And it doesn't have a big overhead. And you can do the same thing. You create custom flight recorder events, right, for used class and used method. And then you use mission control to analyze the output of it. So this is, for example, used class event and used method event. And instead of doing the log output, you just fire these events with using a flight recorder in the code. So the same you see in the static initializer, we just new used class event commit. This will be directly fired. And for the methods, we do the same with the method event. And then after all, in mission control, you get something like this. So this is just the very simple example of doing it, but you can at least figure out the methods that have been called and the classes that have been called at runtime. And the overhead is not really that big. So that's all good, right? So if you would now like to find the unused code, and what do you have to do? You can either use ASM tools. Does someone know ASM tools? They are even used in the JDK. So this is it's a library more or less. And you can use it to get all the classes and methods in your jar file, right? So you run that on all the jar files, then you get a list of all the classes and methods in there. And you can do the same with the class file API since JDK 23. So which will be in JDK 25, which is the next LTS. We will have the class file API, which makes the ASM tools obsolete. So you don't need that anymore to do it. And then you have to create a diff of all the methods and classes that you have, minus all the stuff that was used, and that gives you then in the end a list of all the stuff that wasn't used. That's the idea. You see already it's a lot of work, right? It's not so easy. And then the last part, you have to remove all the unused stuff manually, right? But you can do, so it's possible. And some companies do that. It is a lot of work, but if you have a workflow, you can, with this approach, find code that is not used in production. Okay, nice. So it's possible by a lot of work. Let's take a look at some other solutions, because there must be a different way of doing that. I have two, in principle I have three, but the third one I won't just go into detail because it doesn't really run reliable. So there's JCON. Who knows JCON? Cool. So you all know that. And then you can use Open Rewrite Intelligence Cloud. So I will go into these two. And there's another one which is called Scavenger. And you will find it on GitHub. And I tried it. The problem was the first error message that I got was in Korean. So I was like, okay. And I didn't find really a lot of documentation. So I wasn't able to get it really running. But the idea is very much the same. So if we use JCON, which is Java code coverage, then it's usually made, it's a free tool, it's made to report code coverage on automated test suites. And you can collect coverage metrics through a Java agent, right? When the class loader loads classes, that's the idea. And usually this is used in development, not in production. Well, you can use it to detect dead code or unused code. And for that, I have to shortly explain what a Java agent is. Who knows what a Java agent is? Okay. So if we have the JVM, and this is not only a black box, it has all these ingredients, right? Like we have the class loader subsystem, we have the execution engine, the JVM memory part, and this JVM comes with the API. So once you start the JVM, there is an API, and that makes it possible to talk to the JVM once it's running. And this is the so-called instrumentation API. And then you can use another Java program that goes to this API and talks to the JVM while it's running, right? So, and it can establish something like callbacks to specific subsystems in the JVM. So for example, I'm interested in every class that was loaded. So I installed some kind of a hook to the class loader subsystem. Every time the JVM loads a class, it tells my agent, and then I can save that data, right? So the problem usually is with this stuff that if you don't do it right, you can really bring down the performance. That's a little bit of a problem, but it works. And as I learned today, it works across all OpenJDK distributions. So OpenJDK anyway, but also OpenJ9, right? Because both of these JVMs fulfill the JVM spec. So the Java agent will work on both types of JVM, Hotspot and OpenJ9. So how to find it? You have your jar file, right, with your application, and you run it on your JVM. Once you start it, you attach the Java agent to the running JVM, right? And in this case, if we use JCON, we really have to tell the agent which packages it should really lock the used methods. Because the problem is that this agent is not made for that. It works, but it will bring down performance if you don't do it. If you run it on all the packages, it's not that efficient. And you're probably mainly interested in the packages that you have in your control, so in your company, because this is the code you can change. You can't remove code from Spring Boot, for example, right? So you just have to live with it. But the stuff that is under your control, you can remove. So usually you put it in on your packages only. And then this will go to JCON, and then you have to run it for some time, which is the biggest problem here. Because if we think about, and this is not for everyone, by the way. This is for companies that have old code bases. Usually this is banks and insurance companies and older big industrial companies. And then the problem is, especially in banks and insurance companies, they have these jobs that just run once a year or once every half year. That means if you don't run this test long enough, you will probably find code that is never called because it's just called once a year. So that means you need domain knowledge also to make that work. And then you have to use the JCON CLI to gather the data that you collected. And then you can write it down to a data file, and then again you use the CLI. And because you have now to provide all the information that is available in your jar, so all the classes and methods. And then you can create a report out of it. Right? So this is in principle the workflow if you use JCON. So you can use that. Problem in the end, again, you have to go manually through the report, check all the methods and classes that you might want to remove, and then remove it, okay? So there are two blog posts that are quite interesting if you're interested in this approach. which is one is from Carlos Becker, and he did it on a monolith. I think it was an application server. It's a little bit older, and he shows you how to use JCON to do that. And inspired by this blog post, the company in the Netherlands, Picnic, they run the same stuff on Kubernetes. So they show you how they did it in the Kubernetes cluster and create the reports and create the log files, because it's a lot of stuff you have to set up to make it right. It's not so easy, but you can do it. And it's a valid approach to find that code. Like I said, one of the problems here is, in the end, you have to remove it manually. And if you have this problem that our customer had, that with 70% unused, this is a lot of stuff you have to remove. Right? So it's not that easy, but it's possible. Like I said, problem, you have to remove code manually. That's not so easy. If you use Open Rewrite in Intelligence Cloud, and now I have to pitch it because it's made by Azul, sorry. So we came out with this Intelligence Cloud stuff, and we have something which is called Code Inventory. And it was not our idea. It was an idea of big companies or customers. They asked us for doing that. One customer is Netflix, right? So they use it. And they asked for this, tell us the libraries that are not really used a lot stuff. So we created that, and in combination with Open Rewrite, it's really interesting, because now what you can do. So first of all, it's a cloud service. It collects the data. We use also an agent, but the agent is just for that. It only collects this data, where the JCON agent does also other stuff, right? We can run it on all packages if you like. There is not really an impact on performance. And it offers information about used and unused code. So we give you everything at once. So we give you the methods that are used and not used. And we can find zombie code. And it works like this. Instead of running it directly on one jar, you can run it on multiple jars in a cluster if you like. It doesn't really matter. And then it will automatically start the agent on that machines, collect the data. And now the difference here is we tag the application. For example, you tag it with, this is my app version 1.0, right? And you tag it on all different systems. It could be different JVMs on different hardware, different architecture. Actually, doesn't really matter, because the agents talk all to one forwarder that collects all this information, and the customer has to install it in their own DMZ. So that means it's up to the customer where the internal agents can reach it, and this only has to send out data. So there's no incoming traffic here. And then it talks to Intelligence Cloud, where we collect all that data and aggregate it. And then we have different ways of finding out what is the used and unused code. And again, you have to run it for some time. And if I say some time, I mean 6 months at least for the first run. And probably you need a year or 1.5 years. So it's really a long process to find all the unused code. And then once you finish, let's say 6 months, then you can use the web interface and take a look at the report, and it will look something like this, right? So it's just, this is one of the reports where you see this is used and unused stuff. Not really useful in my eyes, because you have to go through it manually and scroll, and there's a lot of stuff you have to check. It's just a report. You can also download it. That's nice. You can write your own client tool. I did that because we have an API. So you get the same data, create your own report. This is a JavaFX application that I wrote just to figure out how it works. And then I can tell you, because I'm used to this tree view stuff with packages and classes and methods, and I can tell you, okay, this package was used 38%, this class was used 20%, whatever, and give you an overview, and then I can export it to a CSV file or JSON or whatever. And you get additional information. This information is just available. You just have to show it. That's all good. That's nice. But still leaves you to the point you have to manually remove code. And now the difference is, if you use Open Rewrite to do that, then it would be like this. The stuff is in Intelligence Cloud. Open Rewrite has a recipe that accesses Intelligence Cloud, get the data. And now the great part about Open Rewrite is they can analyze the data, and then they can just annotate stuff for you. Instead of removing code directly, they can add annotations to classes and methods that haven't been used. And what they do is, because there's this annotation, and it's available since JDK 9, if I'm right, add deprecated, you can add some string, like code inventory, whatever, and then for removal equals false. That means it's just marked. So as a developer, you can see this stuff in your code base. And you do that after 6 months. And then you run again, right? Let's say another 3 to 6 months, and run the next step. And it will figure out if classes have been called in the meantime or not. It can remove the deprecation, or it can change the flag from unused or for removal true from removal false. And you can remove this or repeat this step over and over again. Right, so it depends really. There's no general rule. It depends on your company and how you use your code. If it's used, if you have jobs that run once a year, then probably you run it for more than 6 months, right? So you can remove this step over and over again. And at one point you can decide, okay, now we did that for, I don't know, 1 year, 1.5 years. You can do a final step and say, okay, now remove the code. And then it will automatically remove all these deprecated methods with removal equals true. And then you can have a merge request that you have to review. Because again, just because we can remove code automatically, you really have to check, because you need people with domain knowledge to make sure that you remove the right code. Even if it's not used, it's always good to have people take a look at it. So the challenges, we have a couple of them. It's continuous deployment. So if you deploy, who does continuous deployment here? So how often? Once a month? Once a week? Someone once a day? Okay. See, that's exactly the problem, because if you add stuff on a daily basis and remove stuff, how to track that? Because the software is continuously changing. So again, the tagging can help, right? So you would deploy version 1 in January, then you tag it with app version 1, 1.1, and so on. You just continue doing that. And when you create these reports, you just filter for contains like this, and then you get all of them, right? And you get them separated in the report. So you can say, okay, this was in this time frame, this was in that time frame. And then you can, maybe you need some tools to merge it correctly, but you can figure out code that wasn't used across all the versions, because this is the problem if you have continuous deployment things, and people do that. So that means you can solve it by using tags, by using this tagging stuff. The final merge request needs really good review, and in any way. The next thing is, what is about code that will be needed in the future? Because if you're preparing features, right, and you commit them, and I was surprised that companies do that. Maybe I'm too old-fashioned, but I thought, oh, you keep it in your feature branch, and then at one point when it's done, you just merge it, and then you deploy it. But I learned that no, companies deploy always to production, even the stuff that is not ready yet. So I was like, oh, okay, interesting. And then you have a problem, because this code is probably not used for the next 6 months, and then suddenly it will be used, because then you turn the switch and say, now the feature is online and now it's used. So how to solve that? That's, to be honest, I don't have really a good idea. You need just people who knows about it, right? Or you just keep them out in the report and say, oh, not this package, because this is the new feature branch. It's these tricky things you have to deal with. And trust me, when I heard that the first time that we do that, I was like, come on, this couldn't be really a big problem. But I figured out that, yeah, it is a problem. So I run it on my own apps. On the app that I showed you, the client, even in this client, only 37% of the code was used. And I triggered everything that I was aware of. So there is a lot of stuff that you write that is not used in production. And these tools can help you to figure that out. So what you get is the ability to find used and unused code. And this also for JCON, you can do that, but it takes more effort to do it. But it's for free. The Intelligence Cloud stuff is not for free. You can run that across multiple JVMs in a cluster, across different architectures at the same time, doesn't really matter. And you have the API. You can annotate and remove code if needed automatically using Open Rewrite. You don't have to. If you need more info, just check out the Azure page. As a conclusion, so zombie code is real, but it's really hard to find. And if you don't believe me, just try it. Use JCON and try to figure that out. It's really impressive how much code is unused in your code base. And monitoring takes a lot of time. And that's the worst part of it. Because convincing people to run something for 6 months without having any results is hard. We can give you results on a daily basis. You can always check, oh, what was used within the last day or the last week or whatever. But this will change over time, right? So this is really not that easy. And also multiple deployments might be a challenge. Tools like JCON and Open Rewrite plus Intelligence Cloud can help you with this stuff. But removing code often needs domain knowledge. This is, I think, the biggest problem. So you need people that really know, not only from the code side, but also from the domain side, when the stuff is used and if it is really used. But that's might be the hard part. So this, I don't know. Well, with this, I'm done. I have no idea about the time. I think it's still a lot of time, right? I think we have 10 minutes. So if there's something you would like to ask me, feel free to do it now. Otherwise, I will be outside later on. Thanks. Oh, and by the way, this scavenger tool is really, it's very much the same as we do. So they do exactly the same. They have an agent, you attach it to your jar. They log it into a local database. I think it's H2, also MySQL works. It should work. As I said, I couldn't get it running on my machine. It didn't really work, and the error message was in Korean, so I couldn't really identify what it is. And I didn't find any good documentation about it. But there is this other tool, and you will find it if you look up Scavenger. So if there are no questions, just enjoy the 10 minutes I gave you back, and enjoy the rest of the conference.